Find the inverse function of f of x is equal to 5 minus 3x over 2. You know what? I'd like to have an idea what this looks like so I can confirm that it passes both the horizontal line test and the vertical line test. So this is equal to, remember, if we have two elements or two terms in the numerator and one in the denominator, I can write this as 5 over 2 minus 3x over 2, which is the same as y is equal to negative 3 over 2x plus 5 over 2. And I know from my days in algebra that 5 over 2, or 2.5, is my y-intercept. And I'm going to go down 3 over 2. And so my graph looks something like this. It's just a rough sketch. And I can see there's the y-axis, there's the x-axis. This passes both the vertical line test, and of course, now I see it passing both the vertical and horizontal line test. I can tell you that we can go ahead and find its inverse. So I'm just going to take that away. Remember our rules. F of x becomes y is equal to 5 minus 3x over 2. Then I switch x and y. X is equal to 5 minus 3y over 2. And now I'm going to solve for this y. Multiply both sides by 2. 2x equals 5 minus 3y. Subtract 5 from both sides. Negative 3y equals 2x minus 5. And I'll divide both sides by negative 3. Y is equal to 2x minus 5 over negative 3. So last step, that becomes f inverse of x is 2x minus 5 over negative 3. I think I have found it. Let's be sure. Well, how can we be sure? Let's find out what f of f inverse of x is. And if we've done this right, it will be just x. So our f rule says take 5 minus 3 times our input and then divide by 2. And our input here is f inverse of x, which is equal to 2x minus 5 over 3 with a negative sign there. So I am going to cancel these 3's, and then I essentially have negative 1 in the denominator here. So I'm going to have 5 minus negative 1 dividing into 2x is negative 2x. Negative 1 dividing into negative 5 is plus 5. You have to be good at algebra for this course. Over 2. Now distribute this negative 1 to both those terms, and I get 5 plus 2x minus 5 over 2. And so 5 and 5 cancels. What's 2x over 2? It is simply x. And so I've confirmed for myself that this is, in fact, the inverse. Find the inverse of f of x equals x cubed minus 4. Well, I know from my days in algebra that x cubed function goes, that's one of the parent functions I know. Minus 4 means we're going to move it down 4. So it looks something like this. And I just asked myself, is it a function? Yes. Does it pass both the vertical line test and the horizontal line test? Yes, I'm in business. Then I can find the inverse. I'm very happy about that. So the inverse will be, remember the first step is f of x becomes y. And now I'll switch x and y. And now I'll solve for y. Add 4 to both sides and we get y cubed equals x plus 4. So y is equal to the cube root of x plus 4, if you know your algebra. Last step was f inverse. Y becomes f inverse of x plus 4. Let's test to make sure we've got that right. Well, one of the tests was you can either use f inverse of f of x equals x, or f of f inverse of x should equal x. What's our f rule? It says take your input, cube it, and then subtract 4. Now our input is f inverse of x. So what does that equal? Well, we just said it was the cube root of x plus 4. What's the cube root and cube? They undo each other, and we're left with x plus 4 minus 4, which is simply x. So look, we found the inverse again. Aren't we good? Find the inverse of f of x equals the square root of 2x minus 3. I know my parent function, that square root y equals square root of x function, is a function that passes the horizontal line test, so it's got to be a one-to-one function. And what am I doing to that function? I'm moving it to the right 3 inside is crazy, cuckoo, bizarro, bonkers, and this is a horizontal shrink by factor of 2. So where is my x-intercept? Well, put a 0 in for y, 2x minus 3. Square of both sides, we get 0 equals 2x minus 3. Solve for x, add 3 to both sides, divide by 2, and we get x is 3 over 2. So I know something. I paid attention in algebra. I know that this function looks something like that. Of course, it passes the vertical line test, and it passes the horizontal line test. Therefore, I know that this function has an inverse. So I'm in business. By the way, to find x-intercepts, we put a 0 in for y. So first step, f of x becomes y. 2x minus 3. Now, switch x and y to y minus 3. Square both sides. X squared equals 2y minus 3. Because I'm going to solve for y. Add 3 to both sides. 2y equals x squared plus 3. And then divide both sides by 2. We get x squared plus 3 divided by 2. So that means the inverse function is x squared plus 3 over 2. I've been showing f of f inverse of x equals x. Let's try f inverse of f of x equals x. We're testing this out now. I think we found the inverse function, but I'm not sure. So the inverse function says, take your input, square it, add 3, and then divide by 2. And our input here is f of x. Well, what is f of x? That's the square root of 2x minus 3. Square root squared, those go off to number heaven, and we're left with this over 2. Negative 3 and 3, they go off to number heaven as well to give us 2x over 2. Cancel, gives us x. By golly, it worked, and we found the inverse again. If you allow me, let's just take a look at these two graphs of that last problem we did. Here was f of x is equal to the square root of 2x minus 3. You saw me find that x-intercept. Well, if I've got this point 1.50, guess what this point is here? You guessed it. This point here will be 0, 3 over 2, or 0, 1.5 for the inverse function. Let's look at what the possible domain of f of x is. What's our smallest x? 3 over 2. All the way out to infinity. Don't include the infinity, but do, because we have a dark blue dot there, do include the 3 over 2. How about y? My eyeball scanned from low to high. This is the lowest y point, so it's going to be 0 to infinity. Now, because I know the domain of the original function, I should be able to blindly, if I got that right, tell you what the domain and range of the inverse are. This should be 3 over 2, infinity for the range of the inverse, and this should be 0 to infinity for the domain. Let's see. Look at the green function. What's the smallest x? Oh, it is in fact 0, and it continues on and on and on. The x is this horizontal distance. Here's our x, and here's our y. That's possible domain, possible range. How about the range? Well, as our eyeball scan, the lowest possible y value is 3 over 2, or 1.5, and we go up to infinity. So it did work.